So I was given the title, Important Things in Future Security, a business perspective. So I put on a suit so it could be a business perspective. Normally I wouldn't do that. This actually is, I have that there because my son was in primary school when that first got introduced into my slides, and I keep forgetting to get it out. This is just me, a security expert, and I'll put this up here because pretty much this will be the last time I talk about security. So you may wonder why I come to a security conference and don't talk about security, and I hope I'll explain that as we go along. I also have to say I am a big supporter of the stuff that John's just talked about. I think that's a really interesting and useful initiative that goes out in relation to that. But these are my framing remarks about what the problem is. I put this in terms of connected and automotive cars, but actually I could have done that for medical equipment. I could have done that. And the thing that I invite you to consider in relation to that, I'm trying to look at the future here for you. It would have been good if we hadn't actually already done this stuff. So if you look at the problems we've got because we've connected the power grid to the automotive system, we've connected that to financial systems, just think about things like the speed that different things are operating. And into that, you're filtering your IoT devices. And to me, this isn't a question of saying, oh, these things are insignificant, they're small, they're little. Actually, this is the future. If you want to know how I'm going to be more economical with power and how I'm going to put it, it's because we're now doing things at scale and we're joining things up. And just think about that. If I'd been talking about this 50 years ago, if I'd been talking about this 20 years ago, anything that we cared about, we would have done at very small scale, done in a very small device. It would have been isolated. But what you're talking about here is, for my NHS, I can put things together because we can analyse the DNA, we can do all these sorts of things, and I can tailor medicine for people. This is how we will be able to maintain our societies. However, this is also how our societies will collapse when we get this wrong. And I think that's a really important thing about it. So this definition that we've I've tried to put up here is designed to actually talk about some of these things. It's designed to talk about, as I say, it's part of a complex hyper-connected system with emergent property. Really important thing, emergent properties. 90% of the value of the economy are properties. Things I didn't plan for it to do. That's an important consideration. So if what we're doing is locking our stuff down so much that we can't get those, that's going to be a problem. We need to be able to take advantage of the way that technology works, of the way that systems work in relation to that. It yields its benefits at scale. It's price sensitive. That's very important. And the automotive systems go really big on this one. So a 2-cent difference in the price of a component and you don't buy it. Anywhere where you're talking about volume, you don't buy it if these are the things. It's really important how you put things together, but it's also, and it's one of the things that came out of the digital security by design, if that is able to reduce my cost of doing security by 20%, that means I can spend 20% more on my innovation. That means I can be more creative. This stuff is a drain. I have to be able to do things elsewhere. So I am really positive about those sorts of things. It's worldwide, mobile. Everything that you've got is moving around on these things. It's not that they're all in one place. We're not locked down into one place in relation to these things. That means you've got different regulations. You've got different trade zones. You've got different things that are happening. And God knows this year, we now have potential catastrophic changes in the world order around these sorts of things. And we have to put systems into that. I'll try to talk there, and it's one of the things that I think is really important. We have both strict and contract liability. For the last 50 years, as software has emerged, we've basically written a thing that says, don't count on it for anything you care about. That usually goes up at the top of the license, or if not in the small print at the bottom of it. But usually you say, don't count on it for anything, which is because we've done anything we cared about in these really small systems. That isn't true now. We care about all these things we're putting together. So when you talk about strict liability, we've moved into an environment where we kill people with these things. Where we have obligations, even if we try and contract out of them. So the things that you're doing matter. The things that I do from a business point of view matter. To fail to consider the security and how that might affect that, is potentially fraudulent misrepresentation. And I was really interested to see Boeing being prosecuted in the last couple of weeks, with a successful prosecution, for misleading the financial markets. Again, a thing that you can't evade, because they told lies about the value of the company. Not because they told lies about how safe their plane was, but they told lies to the financial markets. They lied about the value of their company. That was what, 120 million or whatever it was that went with that one, and $1 million for the chief executive. These things are personal. When you look at the Dieselgate thing, the engineer who did it was responsible. They denied the plea bargain. So these things are starting to be things that matter. You are going to have to consider that the things that you're doing are going to fit into this. And that's why the supply chain stuff will matter excessively. When you get to the bottom section there, talking about intertwined and interdependent components, this is the very definition of a complex system. We do complex systems. We just don't seem to have realised this. And I'm very supportive of looking at SBOMs and things of this nature. However, I think just over 1,100 of the 1,200 cyber attacks that I've evolved over the last 2 or 3 years don't ever touch the code. They change things in the environment, they move things around. I can keep the same code. So that isn't necessarily, it's important, but it is not the totality of the problem. And that, I think, is the really important thing that goes with this. If I look at the car, if I look at things that are going into financial systems, if I look at the areas that we're going into, you'll find it's connected to the satellite systems, it's connected to the telecom systems. The reason I talked about the joining together the power grid and the cars and the financial system, just look at the different speed at which these things operate, and look at the different ways that they defend themselves. And that is a really important thing. We don't talk enough about what are the failure modes. So when I say I don't want to talk about security, it's not because I don't want to talk about security. I will bore for England on security, but it's because that is not my objective. And I want to talk about what is it secure with respect to. I do not want to talk about security as some generic thing. It doesn't mean anything to me. It doesn't. So that, I guess, is what I wanted to talk about in my framing remarks. I'm persuaded by my colleague to put up my principles and things that go through this, talking about things like single bit variations in programs. And the really important thing here, IoT particularly, is not a pure digital system. It talks to the physical world. There is an infinite variability between the physical world and the digital world in which I represent it. And yet I have single bit errors in my machine learning, in my programs, in my data, have completely unforeseen consequences in relation to that. So as John said, we know that we can't get stuff that is, it's not that it's error-free, but that doesn't have unforeseen consequences. And that's what your cyber attackers are attacking. They are not necessarily doing the bits that we've seen. They are exploiting the fact that your system, your complex system, can be stimulated with a single bit error to do something you didn't want it to do. Most emergent properties turn out to be very positive. Some turn out to be very bad. And you have to ride in the face of all of those sorts of things. I particularly like the phrase that says that in our systems, they are determined but not determinable. So that's a really important consideration in relation to that. These are deterministic systems. If you work backwards through it, I can always do that. But if your design is always based on working backwards through things, you will spend all of your money on doing nothing. Many of you who've seen me present before will see that this is my simple definition for what I want out of cyber resilience. And I've put this up because over on this side here, this is the thing that I ask about when we're going through complex supply chains. What have you made strong and what have you made brittle? It's not that I want it to be secure or not secure. What did you intend to make strong? Because almost inevitably you make other things brittle when you move in that direction. So if you fail to understand what somebody was intended to make it secure with respect to, then you will fail to understand how that can be composed into a system. And for IoT devices particularly, that are now so significant into systems, that is going to be a really important consideration. Over on the other side there, the gate is Ashdown Forest. I understand now that people go and visit this gate because of this presentation. It's by the Winnie the Pooh bridge with the poo sticks and things. This is a gate which is a perfectly formed gate. And I apologise here. Yeah, clearly one of the things that John's doing in talking about this is essentially creating a gate. What's unusual about the digital security by design? The next question we can start to ask about that is, how does that enable me to put a fence that's attached to that, and how does it reduce my cost? That is the significant thing that comes with it. But so much of what we do in security isn't that. And I'll give you an example. I gave a lecture in relation to IP routers, because I have to call them routers because I was in the States at the time, talking about which was the better one. So I do routers for commercial use, I do routers for business use, and I do a router that goes on the Airbus that actually delineates things and allows you to use a single ARINC standard for an aircraft bus. Which of those is better? And almost to a person, the people in the audience said, the one on the Airbus. But there was one really good student who said, but we wouldn't have an internet. We wouldn't have the value, we wouldn't even be able to afford an Airbus if we hadn't actually put things together. So to do a cycle-accurate calculation of everything and use that as the example of what an IP thing should be, you can't do that. So this aspect of fit for purpose, what is it you're trying to do? What will it do and what will it not do? What have you made strong? What have you made brittle? It's so important to understanding how you put together and how you compose systems. The one in the middle there, for which I must thank my colleagues at Imperial College, is a single bit corruption of a machine learning algorithm done in real time. That was actually one on a car. So don't buy the car that's on. But it's no different, and it goes as part of these fundamentals. Single bit errors create problems. Yeah, we don't have ways to avoid them, but the consequence of that into the system is to have it completely misjudging how things fit together. You must understand how your systems go into that. This is a very complex slide, so I've made it easier. This is how we join everything together. Yeah, automotive, consumers, energy. That's interesting. What, on an energy management system, on the power grid, how do you fail on that? You fail by protecting the grid. What is the difference between a grid that's actually centrally generated and pumping everything out, and has got everything based on solar cells on my roof and is pumping everything in? But the speed at which you do, the defense mechanisms in relation to that are completely different than those that you get in the financial systems. The ability to get something to calculate, to ask for maximum load, and then not at a center, coordinated across an entire attack surface once every 100 microseconds, causes it not to malfunction, but causes it to behave in a way that actually creates environments that you don't want. Industrial, connected farms, all of these sorts of things. So I thought I'd give you some simpler ones. Some of you may have seen these. These were put together by some colleagues of mine, an organisation called Flint. So we're keen to put, assisted driving, things that are looking at automatic collision prevention. But what this is designed to say is, the way that works is, if it works, that's okay. But when it ceases to work, this is based on machine learning, it's based on AI. What is the mechanism by which you're actually saying this is okay? And you're going to test that in court because people are being killed. But you will also test that in reputation, because when people don't believe what you have said, if you don't have science, engineering, all of the things behind that, if you're not actually able to substantiate what you've said, then you'll get to a situation where you're now deploying things that are not able to be used. So all of these benefits that we want to get will not be things that we'll be able to use. They will collapse as we've moved too far, and if we aren't actually able to rationalise these things properly. I should say these are press articles from 2031. So I expect you to come back to me saying, with the I told you so's in 2031. Here, looking at cyber management plans. I've looked at so many cyber management plans that are actually based around I'm going to do this. And what that does is set down, this is how much it's going to cost me to do these things. This is what I'm going to do in relation to that. You say to the world what it's going to take you to do this. Okay, you don't say, this is how much I'm prepared to spend, and if it's more than that, I don't care. Because you're meeting an obligation. So when you get into a situation where it's perfectly foreseeable that this is not financed enough, from a business point of view, I am now fraudulently misrepresenting what I'm able to do. That is punitive damages. That is, please take away all the things. So when you give me components, when you give me IoT stuff, I need to know how it's going to fit into this, because I am going to be liable for this, whether or not I write a contract that says I'm not. Because I'm having to publish these things now. They are that important to me. And this one here is on single modes of failure. Yeah, the fact that from an attack on a tire pressure monitor, I could actually stop the food distribution network, I can stop medical, I can stop all of these things because it's got a common set of things that go across this. Yeah, these aspects about thinking about resilience as opposed to, what these three are trying to get you to think about is, I am not interested in the security. I am interested in the outcomes that I can achieve because of the security. And even where it is regulated, I foresee that we will move past the regulations very quickly because things matter. They matter more than the regulations. They matter, and this is our future. This is where we are moving to in relation to this. Just to get you to consider something here, if you set up a set of IoT devices in a system that simultaneously has to do privacy, safety, and business value in relation to that, and I asked you what was the failure mode? What is the failure mode of privacy? Usually it's that I stop, I lock it away, I encrypt it. You know, the failure mode of something that's to do with safety, usually I have to continue operating. I don't want that to do. So when you're looking at the components that you do, is it fit for both of those? Can it do both of those things simultaneously? Is that what you're saying when you say it's secure? You know, can you imagine that I encrypted the brake signals and I can't actually get it back? That would be a bad outcome, I would suggest. So this thing is, if you look at our systems now, if you look at our clouds, if you look at our telecoms networks, if you look at our information networks, they are now trying to simultaneously achieve multiple goals because we're fitting these things into them and we are not being clear about what it is we want them to do. We are not being clear about what they're able to do, and we are not concentrating enough on what are the failure modes of these things. And we need to start to do that in order to get somewhere. I thought you'd like a little bit of stats. You can take this to your own industry. So these are recalls based on increasing complexity, you know, coming from the US and the UK in relation to vehicles growing at whatever it is, 6% per annum, with 250,000 expected. This is generally an exponential curve that you're looking at here. So I suspect for all of your industries you could do the same thing. So what you're basically looking at there, I can project when it will be impossible for us to do things by recalling. We actually have to change. We have to be able to do this in real time. Yeah, we have to be able to automate the stuff that we're doing. But how do you do that? You know, these are the problems that we have to solve in relation to that for the future. I put this up, many of you will have seen this before, yeah, about a braking system. This is a braking system, it's an abstract braking system, because it turns out if you go and you actually pick on a braking system that is exactly what one vehicle manufacturer does, they feel you're picking on them. So this is an abstract one, which is why it says you've got between 10 and 23 sensors, 1.5 to 3.5 million lines of code, you've got training data sets in your machine learning. This is what it looks like on a safety critical system. You know, on this we do ABS, city, highway speed, individual braking, acceleration. We control the car, or we don't, you know, as was discovered on the Jeep there. The most important thing about that is we identified as part of that 6 types of generic cyber attacks that will always be present in your systems. Any system of any complexity, we will always be able to say. So if your argument is, I've managed to stop this, then that isn't a good argument. Your argument has to be, how am I managing this? Yeah. And things like the stuff that John was talking about, the digital security, is fantastic, because one of the things that turns out to be really important is, how can I economically manage this? And I think this gives you an opportunity. I think it gives you an opportunity to stop talking about, I've done this much security, whatever that means. It gives you an opportunity to start to regard your IoT components, your security devices, as part of a complex network and as part of recognizing emergent property. Opportunity to be part of the plus side as opposed to the minus side. And I will tell you, if we can start to get to a point where we're not talking about how much security is costing and how that is on an exponential curve to unaffordable, but how it is part of being able to recognize how you might manage to modify your systems to take advantage of things, that will be a much better place for all of us. And I believe it's the only thing that's sustainable going forward. So this is the future that I would like to see, and this is the one I would prefer not to see. And I think if we do not start to pay attention to how we can do this stuff in real time, that is exactly where we're going to end up. And these were just some answers. So recognizing that the security mechanisms are not an end in themselves, contradictions in purpose, recognizing and declaring through a supply ecosystem. And I'll leave you with that because Carsten stood up, so it must be the end of my time at least. And things like pattern of life. Novel security techniques are important things when you start to look at the end use, as opposed to looking at this bit here is good for this. So I think you need to work out where you fit. As an industrialist, I care about the systems as much as I care about the components. And it is not true that the sum of my components necessarily makes a secure system. It is really, really important to understand that. And indeed, it may make a very fragile system. So that bit of actually getting there, we will not be able to walk away from many of these things when we put them in place. If we have saved 50% on the health service budget by doing targeted medicine, to walk away from that is not a feasible outcome. So we have, as engineers, as business people, to work out, how do we do this over the next 5-10 years?